Alright, so welcome back, and today we're going to start talking about when does a limit not exist, okay? Or how do we state that mathematically or in words? What do we mean by the statement that the limit doesn't exist? So before we get in there, I'm going to go over some definitions, some definitions, but some phrasing, okay, and the opposites. So if we look at here, these are the what we would call definitions, right, or phrasing, okay? And then over here would be the opposite of that statement. So here are some statements and their opposites. So one statement that you've seen is for every epsilon greater than 0. Or we also use the symbol, the upside down A, means for all or every, each. So for every epsilon greater than 0 is one way of saying that. That means for all positive epsilon. Here, the opposite of that would say that there exists an epsilon greater than 0 so that. Okay? So I could say for every epsilon greater than 0, the real numbers. The opposite, I would say, is that there exists an epsilon greater than 0 such that it is not a real number. Okay? These are opposites. So this is what we call a universal quantifier, where we would have an existential quantifier over here. So the opposite of all is there exists. Okay? 2, this one says there exists delta greater than 0 so that, well, the opposite of that, now we have an existential. The opposite of an existential is a universal. So here it says there exists a delta greater than 0 so that, yada yada yada. And the opposite of that is to say for every delta greater than 0. Okay? And the third one is a conditional, so an if-then statement, or what we call an implication. If this is true, then this must be true. Okay? The opposite of that is to say, okay, so here, if here it says if this is true, if x satisfies this, right? Then this must be true, right? If there's an x that satisfies this, right? 0 is less than the absolute value of the distance between x and a is less than delta, then the distance from f of x and L is going to be less than epsilon. So again, remember what this means. As we're getting closer and closer to a, then we should be getting closer and closer to L. The function should be getting closer and closer to L. Okay? The opposite of that is saying, hey, there exists an x, so we only need one. There exists an x that does satisfy this, so there exists an x. So here it says for every x, right? If this is true, then this must be true. This is saying, hey, there exists at least one x that satisfies this inequality, but the distance from f to L is actually greater than or equal to. Okay? So it violates that condition needed for the limit to exist. Okay? Okay. So now how would we state this? We would say the limit as x approaches a of f of x does not exist if for every real number L, there exists a real number epsilon greater than 0, so that, or such that, for all delta greater than 0, there exists an x that satisfies or satisfying this inequality such that the absolute value of f of x minus L is greater than or equal to epsilon. Okay? And that's it. So let's do an example of how we would apply this. Have a great day.